Hello, this is James from XRobots.co.uk. This is part 28 of Ultron, the Real Robot. This project series is about building Ultron as a real robot, and as you can see we've got quite a way on with it in the previous 27 parts. This is a real robot with motors and so on that can move. It's going to be partly driven by a motion capture suit, which we've played with in the past to try and move some of those joints around. And it's also going to be driven by its own AI, which we started building in the last 2 episodes. And this is a separate installation essentially, which is Bluetooth connected and floats externally so people can play around with it and see what the reaction is. Last time we put a speech into Ultron so it can tell you what's happening. It only says a couple of things at the moment. We've got a text-to-speech synthesizer and various audio processing. So now it can see you, it can feel you just about with force-sensitive resistors in every joint, and it can also tell you about it. And today we're going to work on that touch sense to try and get the whole robot to move in reaction to touch and other senses. Last time we added this module to the brain that shows where sensing is. So if I go and give Ultron's arm a knock there, we should find that the inner ring shoots round. He also turns his head to look at you, and if I'm lucky I can make it do this side as well. There we go. So the inner ring is shooting round there to say the touch has been triggered, and if we trigger vision, let's just come over here, we should find that the outer ring there shoots round. We also sometimes find the head wobbling is triggering the touch as well, so we need to do something about the sensitivity. Now I've already tuned it up so when vision is triggered, it locks out the sense of touch. But there's still some residual wobble sometimes in the robot that causes the sensors to get triggered in the arm. So we need to do something about the sensitivity of those force-sensitive resistors. Each joint there has a force-sensitive resistor embedded in some slots, which are in between these 2 sections that rotate against each other. So I can actually put packing in the other side. The plan was to pack them out so they're less sensitive, we can block them out so there's not so much force on those force-sensitive resistors. But I can do some adjustment in software to go and tune down that sensitivity because they're linked to an analog in of an Arduino. I'm reluctant to make too many mechanical changes because I think at some point I might rebuild the forearms. So I've got this rather clever clutch system that moves a motor around between 3 worm gears to prioritise which joint to move from the elbow, the forearm twisting, and eventually it'll winch the hand closed. That was a good experiment. I'm not totally happy with it, so I may well just move the motor onto the bicep to move the forearm up and down and put servos in there for the wrist rotation and the hand. So I'm not really sure if that's going to happen or whether the mass is going to be the same. So for now I'm just going to tune up those joint sensitivities in software. Right, I've tuned up that sensitivity in software for those force-sensitive resistors so they're a bit less sensitive. And I've also made the head so that it doesn't shoot back to the middle when it's finished tracking vision. So if I hold this up, we should find that the head will stay there when I've finished. But we've still got enough sensitivity to trigger the FSRs, like so. So it looks over and also the head changes colour again, which I've written back in. So you'll remember a few episodes ago we had a thing that actually smoothed out the motion, and I've written it out for simplicity, but we're going to put that back in as well. So have a look back in part 23 if you want to see how I did the smoothing and the problems I had and the diagnostics I did on that, inspecting the PID controllers and so on. But now I've actually written that back into those 2 head axes. So if I trigger the robot on this side, we should get some deceleration as it stops, and the same on this side. Which does mean there's less wobble when the head stops as well, so it's less likely to trigger itself even though it's locked out if there's any residual wobble, and of course that works for the vision tracking as well. So it's a little bit less jittery. Seems to be randomly catching up saying things there. I was a bit quick with my post-it note. There we go. So that seems to be working pretty well, but what else would you do if someone kept prodding you around? I've coded up some of the other things so there's some other motion now when it turns left and right, so the arm now moves away from you, you'll tell there, and the other side of course as well. And I could make the joints move outwards, so if you push the arm up it would go upwards, but we'll probably need to come back and refine the mechanics there with those force sensitive resistors so that that works really well. He's also saying, hey, what are you doing? Let me get closer.
What are you doing?
And again, the vision tracking still works, of course.
Where did it go? Hey, what are you doing? Hey, what are you doing?
So we've got some quite interesting reactions there, but obviously they're hard-coded. And the purpose of the brain that we're building here is that it will be to think for itself and react differently depending on how it's feeling. So let's see where we are in this diagram that we drew 2 episodes ago. So here's our brain plan that we drew a couple of episodes ago, and it's worth going back for that full explanation. But essentially where we are at the moment is inputs here with touch. We haven't got a temperature or an inertial measurement unit, but we do have vision. Haven't got hearing yet either. And we've got some sort of reflex and reaction processing it and going straight to the output. And the plan, of course, is that some of this stuff as well goes to our other background Arduino that's currently controlling the LEDs, which is going to show visually where we are with the emotions in that brain. That's going to talk to a piece of volition there that's going to decide what it should do through various means. There's probably going to be some memory as well, and those will also influence the output there. So obviously we still get a reflex and reaction if we keep prodding someone. They'll start by jumping and turning around to us, and eventually they'll get bored, and then they'll get maybe angry, and then something else will happen, and that's what we're going to code into our brain. So inside my brain I currently have a bunch of Arduinos. There's an Arduino Mega at the front here, which is controlling this thing, and that's dealing with the reaction and reflex part of the brain. At the back, don't know if you can just see it, there's another Arduino, and that's the one that's going to track emotions and do the other bits and pieces on the back end. That is the speech board we put in last time. So what I'd really like to be able to do is program up the variables in that rear Arduino so that we can track the emotions, and that's what controls all the LEDs going up and down for each emotion. But it'd be really good to have some manual control. So basically I'm going to implement some switches like these, so that in the short term, and in the long term I guess, I can manually tune up each emotion to see what the reaction is. And eventually, of course, those will automatically set themselves from the inputs that Ultron gets. I wanted to design a little switch panel for that shows what the emotions are, so I've just made this little panel here. So we've got happy, sad, that is excited and angry, and that is scared, and that is tender, and these are the emotions we got off the Wikipedia page for emotion, and the ones I've written on that brain map. So the buttons will go through the holes there, and effectively this is going to just sit there, so the buttons and the PCB, it's spaced away from them. So essentially these are opposite things that will tune up, so effectively those are plus and minus buttons that bring those emotions up and down. So we're going to 3D print this on the TAS. It's going to be an ABS print, and I'll solvent weld those 2 pieces together, and we'll just glue it to the PCB, and then we'll think about where to mount it and how it's going to be mounted. Here we are, so I've got that piece stuck there, so my panel now can go over like that, and I can solder my wires to the back. We'll have to see where that mounts though. Right, so here's my control panel, and I've wired that in, and that's wired into that back Arduino to some of the I/O pins because there are loads. So now we can use these buttons as plus and minus buttons to vary the emotions. I've written a little bit of code here that reads the buttons, so those are on the analog pins here for each one: happy, sad, excited, angry, tender, scared. And basically it just keeps track of the variables, so every time you press the happy button, happiness goes up 1, and if you press the sad button it goes down. Similarly, sad becomes greater if you press the sad button, and less sad if you press the happy button, so those things are opposites. And that's the same with excited and angry and tender and scared. And then it basically runs some functions for each one to set the LEDs, and these are at the top here. This is the same as I had last time, counting through, but basically it will colour those in, the neopixels in a loop, so there's a for loop that takes that value passed in for happy, the same for sad, and we'll set those LEDs. I've also done a little test here to control the servos for the fingers on top of the brain. So if happiness is less than 2, then it will move all those servos to the 0 position. If it's more than 3, it will move them to a position of 90, which moves those fingers in and out. And those are going to vary based on something else, but let's see how that works first. It starts in the middle, so you should be able to see 3 happy red LEDs and 3 sad red LEDs. These could be different colours, but as it is, red represents the thing and blue represents essentially a space. So if I take my control panel now and I go happier, we should be able to see happier getting happier and they're being less sad. And obviously if we do this the other way, Now, as we pass a certain point, all the fingers move in on the top of the brain there just for that one as a test. But the next one round, of course, is the middle section there, which is exactly the same. And that last section there, which is exactly the same. So you should be able to see these LEDs moving. The next thing we need to represent in the brain with those colour lights and fingers on top is whether the brain is activated or deactivated. So sort of how much go it's got, I guess, and that will reflect on these emotions and whether that is pleasant or unpleasant. And this was basically taken from the Wikipedia page for emotion, and there's quite a nice chart there, so we're going to try and mix up these emotions to work out what the overall feeling is. Right, I've added 4 more variables now called activated, deactivated, pleasant or unpleasant, and those are combinations of the various other emotions. Obviously some of them are a combination of 4 things, so I've divided it by 4. Some are only a combination. Deactivated is only when it's tender or sad, so that's divided by 2, and so on. And I've constrained those to be a maximum of 6, and I should say with all these variables we could easily multiply those up or give more granularity in them, up to thousands if we wanted, but for now this is just for testing, so we've only got levels of 6 on each emotion. And the more granularity we have, of course, the more combinations we have and the more results we can get and the more interesting things we can experiment with. But in any case, at the moment I'm setting the LEDs on top, the final LEDs, with that activation variable. We could set it with another combination of multiple variables, and I'm putting it out to the serial terminal here so we can see what it is. And it also writes it to the servo controller, so each of those 4 fingers moves in and out based on the 4 sort of quadrants there. So if I open a serial monitor, we should be able to see that they all start at 3 there. And if I start manipulating the buttons, we should find that the fingers move as well as the emotions change. So to make it more activated, I'm going to make it happier. So let's go up there, and we find in fact the activation there is capped at 3 because of the way it's dividing them, because some of them are on the opposite. So as I'm making it happier, it's making it less sad and so on. So we can make it more excited, but that's making it less angry, so we don't get any more activation, but you can see the other numbers changing. And so let's just make it tender, and as we vary these things around, the fingers on top change, the colours change as well. So if I make this very activated, so let's put happy all the way up and excited, and let's make it scared there, so that gives all of the lights purple. But if we make it sad, let's go the other way to deactivated and tender, then we see some yellow getting introduced in these LEDs. So that seems to work pretty well. So now I've got it tracking emotions, but what actual influence does that have? So what we need to do is link those 2 Arduinos together, so the emotions that we've got here can influence the input and the output. So basically half of this is running on one Arduino, the other half is running on the other one. So we can make a 2-way serial link there. So when I touch Ultron or bash it around, that goes and does something to the emotions as well as the sight and the hearing and those other inputs. And then that comes back to influence the output. As I said before, it'll eventually get bored of being pushed around. It'll want to do something else because it'll get angry or display another emotion. And of course we can adjust those manually as well. I also think that eventually it'll be, it'll get over it essentially. So those emotions need to decay. So if it's left for long enough, they'll kind of come down to the middle point again, and it will start to react as it did to start with, unless of course it remembers something there and that has an influence, but I'm not quite sure how that works yet. So for now I'm going to put a decay on. I'm going to make that variable with a knob I can turn just so we can experiment with it. I've written a little bit of code to decay those emotions, so we're using millis, so using multitasking essentially. So at the very start of the loop, we're setting our current millis to the current time, and millis is a system variable that counts how many millis have passed since the system booted. So we're then reading an analog pot, which is 10 bits, so 0 to 1023, and I'm constraining that so the minimum is 2. And then multiplying it by 1,000, so instead of milliseconds we have seconds, so we get a decay of between 2 seconds and 1,023 seconds, which is about 16 minutes. So that's what's happening now. I was just dumping that out to the serial terminal so I can see what value I set on the pot. And here's where the magic happens, which is we check the time. If that's more than that decay time, so we check the clock, and we reset it at the end incidentally as well. So every time this comes around, it resets it and counts another amount of milliseconds set by that pot. And basically it's saying if happy is more than 3, then take off 1, and if it's less than 3, add 1, and it does that to all of those emotions. So every time the counter comes round with however many seconds we've set, it takes 1 off or adds 1, and eventually they all level out on 3 again. Here's my pot here, and it's wired into the analog in of that Arduino, and I've set it right up for the fastest decay, which is 2 seconds. So you should be able to see my happy and sad here. If I increment them up, they go all the way up, and then every 2 seconds we should find one comes off, turns back to blue, that turns back to blue, and you can probably hear the servos working at the top there as the state changes. And that's the same for all of these. So if I press some other buttons and change some other LEDs, we should see them decaying back to where they were to start with eventually.
So I've now made a two-way serial link between the two Arduinos, so my emotions are linked to my reflex and reaction Arduino. So now basically I can send all of the senses off over to here to influence the emotions. So for now I'm just sending one integer, which is going to be for touch, and actually it's a 0 or a 1 depending on if it's touched or not, and that means we can influence the emotions. Eventually that integer will be broken down, we'll encode some more stuff in binary, so we can send the other senses and we can send their magnitude perhaps. For now we'll just send ones whenever it gets touched, and for now we're going to make that angrier basically whenever I poke it around, and the more I poke it the angrier it will get. So that's going to be an unpleasant activation, and I've also got a two-way link here, so I'm sending back, whether it's activated, deactivated, pleasant or unpleasant, sending those 4 variables back as well. So that means we can make the robot react differently depending on how it's feeling. Right, I'm now set up, so every time I poke Ultron, that basically it makes it slightly angrier, and we can see the brain changing as I touch it. But I have put a toggle in so that he has to basically finish be touching and then be touched again, essentially before it makes it even angrier. So it's not constantly getting angrier, sending all those ones while it's being touched. And you can see the activation in the brain there on that circle shooting round. So basically when that's stopped, then it has to be activated again, and that makes it another stage angrier. And we should be able to see the LEDs changing on the angry and excited rails in the middle there. So let's give Ultron a poke. We should see that he's got one stage angrier and one stage less excited. And if I keep doing it, we should see another LED gone. So this one is more red and this is more blue. And let's go to the final stage of angriness. There we go. And we can also see the fingers in the brain here, so getting an unpleasant activation. So there we go. And obviously there's that decay. So at the moment I've set it to a fairly high value with the knob. But if I go and turn that right down to 2 seconds again, we should see that slowly it returns to the middle on here, and we get an equal number of red and blue LEDs. Right, we're now looking at the data sent back from the emotion Arduino to the reflex and reaction Arduino. So we've got those 4 variables there for activated, deactivated, pleasant or unpleasant. And of course excited and angry the opposite, so that leaves it completely in the middle at activated. But as I poke Ultron and make him angry, we should be able to see that the unpleasant and pleasant numbers change. It takes a little while to get there, due to the way they're summed together, and we probably need to look at this a bit differently, so he does get activated, rather than that staying there, but we can see that of course those numbers have changed now, as do the brain numbers. So let's just turn that decay back down again, and we should be able to see those numbers returning to the middle after a few seconds, and there we are. I've now taken the amount of unpleasantness that Ultron feels, which you'll see reflected in this finger here, and now it responds differently depending on how much I keep pushing basically. So if we give him a shove,
What are you doing? Hey, what are you doing?
so that's the normal reaction.
Hey, what are you doing?
Now you'll notice some things changed over here.
Stop pushing me around.
So he's getting slightly more annoyed.
Stop pushing me around.
And if I make that even more unpleasant by pushing the sadness down, or the sadness up and the happiness down,
I will kill you.
then he says some other things again.
I will kill you.
And of course once that value decays, so let's just turn down our decay there a little bit, then we should get back to
Stop pushing me around.
the beginning eventually. Let's just turn that right down so it's speeding up time.
Hey, what are you doing?
So that seems to work pretty well, and of course we can make this much more granular in the future with more granular variables and more influences over those emotions that affect the activation and deactivation and how pleasant or unpleasant it is. So I'm not really sure where I want to mount these controls. There's now a knob and some switches. I think they're going to go on a control panel on the front here. There might be other things as we go.
For now they're just dangling around, and of course there's many more things to go in the brain as well, like our little activation circles. So that's just a really basic demo of where this is going. I hope you can see what I'm doing with this. And as I say, those reactions will be much more granular. The variables and all the emotions in the brain, they'll be much more granular, and there'll be many more things influencing it, which we've got here some things like temperature and sound and vision. Those will influence the emotions. But also we've got volition. So we've got here looking up on the internet and a lookup table and a random seed sort of combined, so that perhaps it can look for phrases online, get reactions from it and decide how to feel for itself, as well as some long-term memory. So I think we're going to have an SD card there packed full of phrases, particular physical reactions that tie up with all of these things. So that's going to get quite interesting. So don't forget to subscribe for more updates on this project and other projects. You can also check out my Patreon campaign at patreon.com/XRobots, where you can get access to some exclusive rewards, including all my videos early and a live broadcast with me. Also check out my t-shirt shop at Spreadshirt. The links are in the description to this video. I have an exclusive limited edition t-shirt design which will not be available after the end of January 2017. Alright, that's all for now.